I was wondering if we could go over geometric sequences and series.
Okay. Let's talk first about the general format for a geometric series, and then you can give me specific problems.
Okay.
So what is the nth term? Well, first of all, let me put up a series. Let's talk about it. If I put up this series, it's certainly not arithmetic, right?
Right.
But it's geometric because every term is the same multiple of the previous term, which is 2.
Right.
Okay? So if we want to talk about the nth term of a geometric series, just like the arithmetic series, it's the first term, but then it's times the common ratio, and that is to the nth minus 1. Now that's a little strange, so when you are remembering this, it's worth testing one. In other words, does the fourth term fit this sequence? Well, so tell me what the fourth term would be.
16.
Well, we can see that, but run it through the formula.
Okay, so a sub 16. No.
Okay, a sub 4, this merely says we're trying to figure out what the fourth term is, based on this formula. So what's the first term?
A sub 1.
Which is?
2.
Correct. What's the common ratio? Or its common multiplier?
2.
And n is 4, so that's going to be cubed. Now, we know from looking at this series, or sequence rather, that the fourth term is indeed 16. Well, is that equal to that? Yes, it is. Now, as all that tells me is that my memory was correct. That's the formula. And depending on how long it's been since you've studied geometric sequences, you're going to want to check that because it's a little different than an arithmetic one. Notice, significantly different. And so whenever you think you have the general formula, it's good to test it just to make sure you got the right one. All right, now give me your problems. What we'll do is I'll stick that up here and we'll do a specific problem.
Okay, so the sequence is 6, 24, 96, and 384.
Now, if that violates the rule for a geometric sequence, even by one number, then it is not a geometric sequence. In other words, if I make that be 383, then that's not a geometric sequence. Geometric sequence has to have that common multiplier between every term. And what is it here? What's R going to be?
4.
Okay, and you can get that if you know it's a geometric sequence. You can get that by just dividing any term by its previous term.
Right.
Okay, what are they asking for?
Deciding whether the sequence is arithmetic, geometric, or neither. Okay,
the only multiplication I didn't do is this last one, but that appears to be correct. It's also a factor of 4. So, this is geometric. And there are plenty of sequences that are neither. In fact, arithmetic and geometric might be the most common, but there's a lot others. It's just the only two they're teaching you at this point in math. So it's geometric. What else do they want to know about it?
Then they said explain your answer.
Okay. What would your explanation be?
Every crap, what's the
term? Every term.
Every term is multiplied by 4.
I would say every term is a multiple of 4 over the previous term. And for it to be a geometric sequence, it has to be some multiple. It doesn't have to be a multiple of 4. In fact, maybe the correct answer is it's a geometric sequence because every term is a constant multiplier of the previous term.
Right.
Okay, what else do I want to know?
That was all for that one.
They didn't want to know what the 12th term was?
No, there's different parts of the...
Okay, we'll get to that, in other words, is what you're saying?
Yeah.
Okay. Because that's usually what they do, is they want to know certain terms. Okay, what, give me another one.
Okay, 1, 4, 16, and 64.
Is that a geometric sequence?
Yes.
Yeah. Now, to really prove that it's a geometric sequence, you kind of have to do every term. In other words, you have to know that 4 divided by 1 is 4, 16 divided by 4 is 4, and 64 divided by 16 is 4.
Right.
So you kind of have to check it, because if I made that number 63, it's not a geometric sequence, and yet you would still have a multiplier of 4 there and 4 there, and if you quit too soon, you might assume it's a geometric sequence, but it isn't, if that was a 3. But it's a 4, okay. Now what?
It says find the common ratio of the sequence.
Okay, what's the ratio?
4.
Okay, what else? I mean, is there any other question with this particular problem?
Oh, no, that's all for this one.
Okay. Let's have some harder ones. These are awfully easy.
Okay.
We only have a half hour. We don't want to spend the whole half hour on these problems that you know how to do. I can tell you know how to do these. So let's give me one that you don't know how to do.
Okay, so this section is writing a rule for the nth term of the sequence, and it's r equals 3 and a sub 1 equals 4.
Okay. Give me this one with those filled in.
Okay, so a sub n equals 4 times 3 raised to the n minus 1.
That's the answer.
Oh, that's the answer?
That's the answer. Notice the only thing missing is an n. So I can tell you what the second term would be. I can tell you what the 200th term would be.
Right, okay.
In other words, a sub 3 would be 4 times 3 to the 3 minus 1. That's just a number. That's 36. So a sub 3 would be 36.
Oh, cool.
All right. So these general nth terms, these are important to know. Just so you remember, arithmetic is this. A sub n equals a sub 1 plus the common difference times n minus 1.
Right.
That's arithmetic. And notice the biggest difference is in the geometric, the n minus 1 is the exponent. Whereas in the arithmetic, the n minus 1 is just multiplying.
Okay.
Okay. I'll leave both of those up. What else you got?
All right, so for this next one, there's two parts to it. The first part is finding the sum of the first n terms of the series. And the second part is
it arithmetic or geometric, or do we know yet?
It's geometric.
Okay.
And then the second part is finding n for the given sum. So the series is 1 plus 4 plus 16 plus 64.
Dot, dot, dot?
And then,
no.
Yeah, dot, dot, dot.
Okay.
And then, so the first part, it gives you n equals 14.
Okay. So if n equals 14, what they want is s sub 14. This stands for the sum of the first 14 terms.
Okay.
Now, obviously, we don't want to write them all out, because that'd be
Right.
it'd just be a lot of writing. I mean, this could be the sum of the first 41 terms. There is a general formula for this. Do you know what it is?
Yeah, s sub n equals a sub 1, parentheses 1 minus r to the n over 1 minus r.
Like that?
The a sub 1 is multiplying the
That's what I got
1
it.
minus. Okay.
So it's a sub 1 times the quantity 1 minus r to the nth power, right?
Yeah, and also over 1 minus r.
Okay. So let's plug everything in that we know. What's a sub 1?
A sub 1 equals a sub 14.
No, a sub 1 always equals the first term in the sequence or the series.
Oh, okay, right.
Same thing as this a sub 1 over here on the right. That's what a sub 1 means, the first term. A sub 2 means the second term. A sub 4 means the fourth term. This, where they're asking you the sum, if they would have said, well, let's go ahead and fill everything we know in here, and we'll figure it out. But, no, let's stop for a moment. I couldn't remember exactly what this formula was. So let's see if it's correct. I'm going to test the first 3 terms. In other words, what is s sub 3 according to this formula? Should it be? What's a sub 1?
Oh, a sub 1 is 1.
Going to multiply it by 1 minus the common ratio is what? Look at that series at the top. Every term is what? Multiple of the previous term.
Oh, 4.
Okay, so it's 1 minus 4, and we're doing s sub 3, and the reason we're doing s sub 3 is because I want to verify I can easily add those 3 terms. It's 21. So let's make sure we get 21.
Okay.
When we do this math. If we get 21, then you probably have the right formula. Okay?
Okay.
Well, what is this? 1 minus 64 is 63. Negative. And the bottom is minus 3. Well, what's that equal to? Positive 20.
Positive 21.
So, we got the right formula. And it's always nice. I could have looked it up in my book or online, but I prefer to prove it by doing a low-numbered one where we can actually physically add it together pretty easily. It's going to be hard to do that with s sub 14. That's why this formula is very helpful. Because when you get big s sub bigs, you're getting big numbers. So what's this going to be?
That equals 1 parentheses 1 minus 4 to the 14 over 1 minus 4.
Do you have a calculator?
Yeah.
Go ahead and figure out what 4 to the 14th power is.
Oh boy.
It's going to be a big number.
Yeah, 268,435,456.
Now that's what 4 to the 14th is?
Yep.
So what is 1 minus that?
Negative 268 million.
Yeah, what's the last digit?
Okay, 455.
That's all I needed. Okay, so that's the numerator. We're dividing it by -3. So I guess the only way you're getting that is with that calculator.
Right.
And you know it'll be a positive number, as we can see. No matter how many you sum up, it's going to be positive.
Yep. Okay, I got positive, let's see, 89 million, 478,000, 485.
Perfect. Now, no, that's how you do it. Okay?
Okay.
So the secret to all of these really is memorizing these. The nth term formulas and the sum formulas. Now there's also a sum formula for an arithmetic series that's different than this one. This is a sum formula for a geometric series.
Okay.
You probably don't have any problems for the arithmetic because you're done with that and you're on to geometric now, right?
Yep.
Okay. Hold on, let me make some room here. What else? Here, I don't need this one up there anymore. I'll leave this one up there just in case you have another sum problem.
Yeah, so the second part is finding n for the given sum.
Okay.
And it gives us S sub n equals 341.
For this same geometric sequence?
Yeah.
Okay. So here's what I got. 341, that's S sub n, equals, well, I know S sub n is A sub 1, which is 1, times 1 minus 4 to the n, all over minus 3. So there's my equation, and I have to solve it for n. What am I going to need to solve it for n? Well, maybe, maybe not. Have you had logs?
Yeah.
Okay. You may have to use logs here, you may not. What I basically, let's see whether we have to or not. In other words, usually when your variable is in the exponent, it's a log problem. Unless you can do it without using logs, if it happens to be perfect cubes or perfect fourths or something like that. Now, I can write that numerator. We've already found that I can write it as negative 4 to the n minus 1, right?
Right.
In other words, that's what we kept doing, is we'd find 4 to a big power, we'd subtract it from 1, and the answer was 1 less than that number with a negative sign on it. So now I'm going to take that 1, move it to the other side to give me 342. That's equal to negative 4 to the n. Well, let's see. I think I need parentheses around this. No, I don't. Yeah, I must. Nope, don't necessarily. Yeah, I have to have parentheses around it because otherwise I'm going to come up with a negative number here. In other words, if I take 4 to the nth power and put a negative sign in front of it, I got a negative number, and that can't be, so it must be like that. Now, we know that 4 cubed is 64. 4 to the 4th is 256. Oh, I forgot this negative 3 over there, didn't I?
Yeah.
That's what's going on. Okay. Boy, it's terrible. When you make a little mistake in math and you don't catch it when you make it, you never recover from it. You can't figure out what's going on. So let's first take this minus 3 and multiply it. So that should be, let's see, 1023 maybe? Think so?
Yeah.
Okay. And that's going to be negative. Now I got it perfect. I can do it the way I was going to do it in the first place. I don't necessarily have to do it. You know, I don't need to be tricky here. Let's just write it as it's written. 1 minus 4n, 4 to the n. Okay. Now let's move that 1 over. Makes it 1024. And that's equal to negative 4 to the n. I can divide both sides by minus 1. Now, 4 to what power equals 1024? Well, notice 4 to the 4th is equal to 256. If I multiply 256, I'll bet it's 1024. So the answer is n equals 5. In other words, I was able to solve this one for n without using logarithms only because n was a solid or a whole integer number.
Right, okay.
If it would have been 5.11746, then I'm never solving it without logs. So they made it easy enough that we could solve it without using logarithms.
Okay.
Okay? But normally, that's not the case. In other words, here, let me give you another example of what I'm talking about. If I say 8 equals 2 to the x, can you figure out what x is?
Yeah.
It's 3. But if I say 7 equals 2 to the x, can you figure out what x is?
Nope.
Now, without using logs. You can if you use logs. I take the natural log of both sides. That allows me to bring the x down into front. And I got x equals the natural log of 7 divided by the natural log of 2. That's a number you can get out of your calculator.
Right.
So that's just an illustration where when your variable is in the exponent, typically you're going to have to use logs unless they've given you a particular easy one that can be done without logs, like this last one. By easy, I mean not necessarily an easy problem, but I don't need to use logs to solve it.
Right.
We'll change that back to n. This is the general formula for the sum.
Okay.
There's an interesting story. One of the greatest mathematicians was named Gauss. And when he was 8 years old, his teacher said, "What's the sum of the numbers from 1 to 100? He came up with it in about 4 seconds because he had the formula. Although I don't know that he necessarily did it by the formula. The way he did it was he knew that 49 and 51 were a pair that added to 100. And 48 and 52 were a pair that added to 100. And you could basically do that all the way down to 1 until you have 50 pairs that add to 100. So that's 1,000. And then you got 150 left over. So the answer was 1,050. And that's how he did it, I think. As opposed to using the formula, which that's another one that I would have to play with a little bit. I don't remember it exactly, but I remember it. It's something like a to the 1 over 2 times the first term plus the last term or something like that. I believe that's the sum of an arithmetic series. But we're past that, so we don't need to go over that. And before I accepted that, I would test it on a really simple arithmetic series like 1, 2, 3, 4, 5. Or 1, 2, 3, 4. I know that adds to 10. So, all right. What else do you have, Jake? We got about a couple of minutes. We got time for one more if you want.
Okay, so this one has a sigma, I think it's called.
Okay. This term right here.
Yeah. All right, so there's a 12 above it. And then I equals 1 on the bottom.
Okay, so they're using I equals 1 to 12?
Yeah.
Like that? This variable can be anything. It can be n, it can be k, doesn't matter.
Right.
Okay, and what's the function?
Okay, it's -2 to the I minus 1.
Okay. What do they want to know?
They want us to find the sum of the series.
Using, let's first of all make sure we understand what sigma means. What's the first term of this series?
-2.
Substitute 1 for I. What's -2 to the 0 power?
0.
1. Any number to the 0 power is 1.
Okay.
So there's the first term. Plus, what's the second term? I is now 2.
Would it be -2?
Correct. What's the third term? Now, there's something very important here, and is there a parentheses around the -2 or not?
Yes.
That makes all the difference in the world. Because now that exponent is operating on that negative sign also.
Right.
Okay. The first two terms are still correct, but the third term it would have mattered. So what's the third term going to be?
That will be -4.
What's -2 squared? -2 times -2.
It's 4.
That's the third term. What's the fourth term?
-8.
Notice what's happening here. The sign is alternating, and we have a geometric series. Right?
Right.
What's the next term going to be? Don't do the math. Just look at our series. What do you think the next term is going to be?
Positive 16.
And the term after that?
Negative 32.
Okay. So we don't need to go all the way out to the 12th term and then add them all up. We can use this. What's
Okay.
the common ratio in this particular series? In other words, what do I have to multiply each term by to get the next term?
Negative 2.
Correct. A sub 1 is what?
1.
Okay, now let's plug it in.
All right.
So the sum of the first 12 they wanted?
Yeah.
Okay, it's going to be A sub 1 times 1, what? Tell me the rest of it.
1 plus 2 to the n.
Actually not. It's 1 minus, and we know that r is minus 2, and it's r to the n. So at this point, I cannot cancel out both negative signs and replace it with a positive. This negative sign is subtraction. This negative sign is part of what is being taken to the nth power. Okay? So, and it matters and instead of n, that should be 12. What goes in the denominator?
1 minus negative, or 1 plus 2.
3. Don't need that. So we need minus 2 to the 12th. That's going to be a positive number. And then we're going to subtract that positive number from 1. So the number is actually 2 to the 12th minus 1. That's the numerator, correct?
Yeah.
Because we know even though it's minus 2, it's going to turn positive. So minus 2 to the 12th is the same as 2 to the 12th. And then,
Right.
I got this backwards here. I don't know why I insist upon trying to do that little trick. Don't need to. It's 1 minus 2 to the 12th, all divided by 3. Notice that is going to be a negative number. Well, that's okay because the second term is negative, the fourth term is negative, the sixth term is negative. We can tell that all even-numbered terms are negative. So we should get a negative number. So whatever that is, you can do it in your calculator if you want. 1 minus 2 to the 12th, and then take that answer, divide it by 3. It's going to be one of those giant numbers again. I don't know why. I guess they insist upon doing that so that you can't really do it manually. In other words, when you use a number as big as 12, it's very difficult. I mean, I did the first 6 terms. I wouldn't really want to do the next 6 and then have to add them all up.
Right.
So even though you have a sigma, basically that's what that means. When you're looking at the sum of the first x or n terms, that's what sigma says.
Okay.
Okay, by definition, that's a way to look at the meaning of that sigma. All right, Jake, I will talk to you next Monday night.
All right. Thank you.
You're welcome. Bye-bye.
Bye.